let's say next law of exponent, which is a raised to m whole raised to n. Please try to understand what is happening here. So here inside the bracket, if you see, it is a raised to m, which means a is multiplied m number of times, and this is whole raised to n, which means a raised to m is multiplied n number of times. So if I have to expand this one and write using exponents, using the expansion, then what will it be? This will be a raised to m into a raised to m into a raised to m. So like this we are going to multiply a raised to m n number of times. So by applying the first law, so what do we get? So it will be the first law, if you remember, a raised to m into a raised to n. If I am multiplying two exponents with the same base, then the powers get added up. So here I have all the exponents with the same base, the powers will then get added up. So it will be m plus m plus m, so on up to m. So here there are n m's. So this I can write it as a raised to m into n. So let's take an example. For example, let's say 2 raised to 3 whole raised to 2. So I am multiplying 2 raised to 3 twice. So essentially it is 2 raised to 3 into 2 raised to 3, which will be 2 raised to 3 plus 3, which will be 2 raised to 6. But we don't have to do this every time. We can use this law and we can directly write this one as, instead of writing step by step like this, we can directly write this one as 2 raised to 3 into 2, which will be 2 raised to 6, which will be same as this one. Let's take one more example. Let's say, for example, 3 raised to 3 whole raised to 10. Now if you want to write expand and write, then you have to write 3 raised to 3 10 number of times. Tedious task. Instead you apply the law. So it is a raised to m whole raised to n will be a raised to m into n. So 3 raised to 3 whole raised to 10 will be 3 raised to 3 into 10, which will be 3 raised to 30. Now we study one more law of exponents, which is a into b whole raised to m. So here what we are doing is we are multiplying two bases here, like a into b, and that whole is multiplied by m. So this, first let's expand and write, let's see what happens. So if I expand and write this one, so this is a into b multiplied m number of times. So a into b one time into a into b twice into a into b thrice. So like this we are multiplying a into b m number of times. So there are m times a into b. So by commutative property we can rearrange these multiplications. So what I'll do, I'll rearrange the a's and b's. So I can write this one as, I'll group all a's together. So I can write it as a into a like this a. Now can you tell me how many a's are there here? If you see, in each term there is one a. So like this there are m number of terms. So which means how many a's are there? There are m a's. Again m a's are there into, now let's write b's. So it will be b into b into b like this into b. So how many b's will be there? Again in each term there is one b. Like this there are m number of b's. So this will be again m times. So now here a is now multiplied m number of times. Here b is now multiplied m number of times. So a multiplied m number of times, I can write it as a raised to m into b m number of times, I can write it as b raised to m. What do we understand from this equation is that if the bases are multiplied and it is raised to some power, then you can take power separately only if the bases are multiplied. So a into b whole raised to m can be written as a raised to m into b raised to m. So let's take a simple example. Let's say 2 raised to 3 whole raised to 2 into 3 whole raised to 4. Now can be written as, since the bases are multiplied, I can take 4 separately. So it is 2 raised to 4 into 3 raised to 4. Converse is also true. Most of the times we apply the converse. So if I have a same power and different bases, then I can write it as a into b whole raised to m. So let's take an example. Let's say 4 raised to 3 into 3 raised to 3. So what is this equal to? Now if you see, bases are different here, but the powers are equal. So we can apply this one conversely. So I can write this one as 4 into 3 whole raised to 3. So 4 into 3 is nothing but 12. So it will be 12 raised to 3. Very simple. Now we'll study the next law, which is a divided by b whole raised to m. So in the earlier law we had a multiplied by b, which means the bases were multiplied. Here the bases are divided. So when this is the case, so what does this mean? A by b whole raised to m. What does this mean? Here we are multiplying a by b m number of times. So let's write that. So exponent, right? So it is a by b into a by b. So like this into a by b, like this we are multiplying m number of times. So since it's a fraction multiplication, you multiply numerators and you multiply denominators. So we get a into a m number of times divided by b into b m number of times. So essentially this is a raised to m divided by b raised to m. Same law whatever we understood previously. So if the bases are multiplied, you can take powers separately. If the bases are divided, then also you can take powers separately. So let's take an example. For example, let's say 5 by 3 whole raised to 5. So this one can now be written as, since bases are divided and 5 is the common power between them, you can take 5 raised to 5 divided by 3 raised to 5. You can take 5 separately. So it will be 5 raised to 5 divided by 3 raised to 5. Most of the time we apply the converse, which means if I have different bases and the same power, you can write it as whole raised to power. Let me take an example. For example, 6 raised to 6 divided by 3 raised to 6. Now see here. So we have same power and different bases. Since there is a same power, we can write this one as 6 by 3 whole raised to 6. So this 6 by 3 you can simplify it as 2. So it will be 2 raised to 6.